first, then second, minus the reverse ratios. First, second, first. So curly phi by curly pi and curly psi by curly qi. Okay, this total quantity is known as the Poisson bracket of phi and psi. Is it okay? Now these are the properties for the Poisson bracket. We will discuss it, but you can solve all these because these are just using the definition can be obtained. Like phi psi will be equal to minus psi phi. Okay, the right hand side will be psi phi. So psi phi will be summation I from 1 to n curly psi by curly qi and curly phi by curly pi minus curly psi by curly pi curly phi by curly qi. So it is the negative of phi psi. If we will explain the right hand side, then it will be the negative of the left hand side because the phi and psi are interchanged. Okay, so the first property holds. The second property states that the first function is c phi and second function is psi. So c phi psi, the Poisson bracket will be equal to constant will be taken as the common part and then Poisson bracket of psi phi. So c phi. So in one replace phi with c phi. On right hand side it will be curly by curly qi of c phi, curly psi by curly pi, and then curly c phi by curly pi, curly psi by curly qi. Now all of you know the derivative of ay, it will be a into derivative of y. So it will be c into curly phi by curly qi, curly psi by curly pi minus curly phi by curly pi, c into curly phi by curly pi, curly psi by curly qi. C can be taken as the common part and the right hand side is obtained. Similarly, the next one, the Poisson bracket of the functions phi plus psi and chi. There are two functions. First function is phi plus psi and second function is chi. Its Poisson bracket will be equal to phi chi plus psi chi. This minus is not there. So in the equation 1, replace phi with phi plus psi and psi with chi. I think you can solve it. After that, there will be curly by curly t of phi psi. It will be partial derivative of phi and psi, its Poisson bracket, plus phi into partial derivative of psi with respect to t, its Poisson bracket. What will happen? Phi psi can be taken from equation number 1. And now find out the partial derivative of right hand side. So on right hand side it will be summation I from 1 to n curly by curly t of first function minus curly by curly t of second function. And now the first function is also a product of two functions. So u into v method will be applied. Similarly in the second part, u into v method will be applied. So on the right hand side two terms will be obtained. Is it okay? Now I think you can try these 4 parts. If found any problem, we will discuss it. But try to solve these by today. After that, we are having the Poisson identity. It states that if we are having 3 functions, x, y, and z, then the Poisson identity is Poisson bracket of x, y, and then Poisson bracket of that function with z, plus give the cyclic shifts. Poisson bracket of yz, and for that function take the Poisson bracket with x, plus Poisson bracket with zx, and then take the Poisson bracket with y. The sum of this term will be 0. So for the proof, basically it's really very simple one, because just we have to find out the Poisson bracket of x, y. So it will be summation I from 1 to n curly x by curly qi, curly y by curly pi minus curly x by curly pi and curly y by curly qi. Taking y comma, so it will be summation I from 1 to n curly by curly qi, curly by curly pi plus minus curly x by curly pi, curly by curly qi of y, represented like dxy. So xyz, it will be dx dyz. When it was xy, we had taken dxy. When it will be xyz, it will be dx dyz. Because z is taken as the common part. So in all xyz plus xyzx plus zxy, it will be dx dyz plus dy dzx plus dz dxy. And now just try to obtain this Poisson bracket. Means xyz. It is written directly here, but when we will find out the first Poisson bracket xyz, so it will be xy. Xy is this quantity, and then it's Poisson bracket with z. It means partial, or rather we can take this quantity, the first one. So the Poisson bracket of first function with respect to qi means curly by curly qi of summation I from 1 to n curly x by curly qi curly y by curly pi minus curly x by curly pi curly y by curly qi into curly z by curly pi, and then minus curly by curly pi of summation this quantity and into curly z by curly qi. When we will evaluate, there will be, I think, total 8 terms in the first one. Then in the second one, again there will be 8 terms, and then in the third one there will be 8 terms. Now, adding all those terms, there will be some positives, some negatives will be cancelled out, and at last we will receive that will be 0. Okay, so it's the Poisson bracket. After that, there is a remark. Just keep it in mind, then if we are having 3 functions, then finding their Poisson brackets and giving the cyclic shifts, their sum will be 0. Now this is the definition of the integral or solution of the equations of motion, means Hamilton canonical equations, that a function f t q I p I is known as the integral of the equations of motion if for any motion of the given system this function retains a constant value, means f t q I p I will be equal to c. And now the remark is that the necessary and sufficient condition for a function f t q I p I to be the integral of the equation is that curly f by curly ti plus Poisson bracket of fh should be 0. H is the Hamiltonian function. So f is a integral of the equations 1 if curly f by curly t plus fh is equal to 0. Okay. Now, Jacobi-Poisson theorem, it states that if f and g are integrals of the equations of motion, then their Poisson bracket is also an integral of these equations. If two functions are the integrals, then their Poisson bracket is also the integral of the equations. So if f and g are the integrals of the equations of motion, then it will satisfy according to the remark. Equation 1 and 2 means curly f by curly t plus fh will be 0 and curly g by curly t plus gh will be 0. Now to prove that fg is also an integral, what we are to prove? That curly by curly t of fg plus fgh will be 0. Okay, let's find out curly by curly t of fg. According to remark 4, it will be curly f by curly t g plus f curly g by curly t equal to 0. Now curly f by curly t can be obtained from equation 1 and can be replaced in 4. Similarly, curly g by curly t can be obtained from 2 and can be replaced in 4. So from 1 it will be minus fh and from 2 it will be minus gh. Replacing those values in 4, what we will have? It will be minus fhg and minus fgh. Or we sorry. Or these can be written like curly by curly t of fg is equal to minus, no, this minus is not there now. It is hf using the first rule that phi psi is equal to minus psi phi. So minus fh is hf. So hfg and plus, minus is not there, plus f is the first function, gh is the second function, and minus is outside, so it is replaced. So it can be written like ghf. And now curly by curly t fg plus fgh will be, these minus are not there, all terms are positive, hfg, ghf, and then fgh. Using the Poisson identity, this sum will be 0, and so curly by curly t of fg plus fgh is 0. It means fg is the integral of the equations of motion. Okay, leaving it today here. Tomorrow we will discuss the Lagrange brackets. Always you will try to solve all the problems stated in the 3 pages that we have discussed.